All right, so welcome back. Today we're going to be doing section 4.6, which is more trig graphs. Specifically, we're going to be taking a look at tangent, cosecant, and secant graphs, kind of looking at their periodic properties, going over how to graph them step by step. I'm going to do two parts. Part one is just going to be solely graphing tangent, cotangent, cosecant, and secant in detail. That's going to take a little while. And then we're going to jump to graphing or the transformations and taking a look at amplitude, period, and phase shift. That will be part two because I don't want to make the video awesomely huge. So I'm going to make two parts to it because each is going to be long enough as it is. So I'm going to get right to it because I don't want to take up too much time. We're going to start with tangent and cotangent, talking about when they complete a cycle. So I'm going to go ahead and start with talking a little bit about tangent. So tangent completes a cycle between negative pi over 2, which is different, to pi over 2. Now, if you were to count from negative pi over 2 to pi over 2, that distance is equivalent to pi. So a period of tangent and cotangent completes a cycle at pi distance, but in this case, tangent starts at negative pi over 2 and ends at pi over 2, okay? So even though this completes a cycle between negative pi over 2 to pi over 2, this is a whole cycle of pi. Okay, so that is for tangent. Now for cotangent, this one completes a cycle between 0 and pi. So again, from 0 to pi, the distance is pi units. So therefore, both of them have a full cycle completed in the distance of pi, even though tangent starts from negative pi over 2 and ends at pi over 2, and cotangent starts at 0 and ends at pi. So we say that tangent, theta, if we add multiples of pi to it, it's going to give you a cycle of tangent over and over again to negative infinity and to positive infinity. You're going to get the same graph every time you add pi or subtract pi. And for cotangent, the same thing is true. If you add pi to that, you're going to get a cotangent theta graph over and over again, cycled over and over again every time you add any pi to that, 2 pi, 3 pi, 4 pi, etc. Okay, so again, that is the period of cotangent and tangent, which is pi distance. And for the domain, which I like using blue, the domain for tangent, you're going to notice, is that the domain is theta. Let me see if I can draw a dot. Theta such that theta cannot equal to, or it's undefined at pi over 2, or any multiple of it. So for example, you're going to notice that tangent theta is undefined at negative pi over 2, at pi over 2, and any multiple of that, okay? So literally there's going to be a dashed line there indicating stop graph. You cannot cross this line because it's undefined here. And for cotangent, something similar happens, but instead of negative pi over 2, and anything equivalent to that, we say that the domain is theta such that theta cannot equal to or is undefined at pi and any multiple of that. So for example, at pi, it's undefined. You cannot cross the graph there at 2 pi, 3 pi, 4 pi, 5 pi, etc. Cotangent cannot cross the graph, and you'll see undefined dashed lines that we're going to be drawing when we graph the trig functions for tangent and cotangent. Now, I'm going to go ahead and jump to the period for secant and cosecant. And again, if you need to slow down and rewind, you can, because it is a video. I'm trying to keep it kind of short so that it doesn't take a long time to kind of upload to YouTube. Now, for the period of secant and cosecant, it's 2 pi. So they both complete a cycle between 0 and 2 pi. And the reason for that, you probably already guessed why, is because secant is the reciprocal of cosine. So secant is 1 over cosine theta. And cosecant is the reciprocal of sine. That's 1 over sine theta. So they're connected in that sense that they're going to have the same period in which they complete a cycle. But again, we're going to see that the graph isn't going to look exactly the same because, again, they're reciprocals of cosine and sine. Okay, so I'm going to go ahead and jot that down here. Both cosecant theta and secant theta complete a cycle between 0 to 2 pi, just like sine and cosine. Okay, so if we were to take secant theta and add multiples of 2 pi to that, we're going to see secant theta repeating itself over and over again. And the same is true for cosecant theta. If I add multiples of 2 pi to that graph, you're going to see cosecant theta repeat itself over and over again every 2 pi radians. And so for our domain for secant and cosecant, for secant theta, we say that the domain is theta such that theta does not or cannot equal to or is undefined at pi over 2 or any multiple of it. Okay, so negative pi over 2, and any multiple of pi over 2. And for cosecant theta, we say that its domain is theta such that theta cannot equal to pi because it's undefined at pi, and any multiple of pi. So 2 pi, 3 pi, 4 pi, etc. And also negative pi, negative 2 pi, negative 3 pi. You'll see that there's a line that is a dashed line that we're going to draw that says, hey, this is undefined. You cannot cross this path. Okay. All right. So with that, let's go ahead and jump to graphing. So graphing is going to take a little bit of time because I need to justify after we write down the radian numbers here, how do we find the values of tangent theta by those radian numbers? And we have to remember one big thing is that tangent theta, remember, is sine theta over cosine theta. Okay, and that's going to be important because in our unit circle, which I have in the next slide here, you're going to notice that these values are just x and y, cosine sine, cosine sine, cosine sine. Where the heck is tangent? Well, like we're going to talk about, tangent is equivalent to sine over cosine. So we're going to be doing some division in our calculator in order to fill out this part right here. So let's start off with first talking about when tangent completes its cycle. And we said it completes its cycle between negative pi over 2, and let me put comma instead of 2, to pi over 2. Okay, that's when it completes a full cycle. So this first value, we're going to use negative pi over 2, and at the end, we're going to use pi over 2. And if you look at the unit circle, basically what we're doing here is we're filling in the values, let's say if 0 were in the middle, this would be equivalent to pi over 3, or actually pi over 6, pi over 4. So let's say you started at 0. The first radian is pi over 6. This is pi over 4, and this is pi over 3. And if we go backwards, this would be negative pi over 6, negative pi over 4, and this would be negative pi over 3. And that would take care of, again, the first quadrant and also the fourth quadrant, because if you recall, negative pi over 6, or excuse me, negative pi over 2 is down here, and positive pi over 2 is up here, right? We talked about how when we measure the unit circle going clockwise, it starts going in the negative direction, okay? And if we go counterclockwise, that's where we get pi over 2 and pi, 3 pi over 2 and 0. But if we count this way, this would be negative pi over 2, negative pi, negative 3 pi over 2, and then back to negative 2 pi if we go clockwise, all right? So, all right, so what does that mean? We're going to be focusing our attention then on the first and the fourth quadrant, okay, of this graph. And specifically, we're going to be looking at the sine and cosine values here. So we're going to be looking at these. Remember that sine represents y. So I'm going to go ahead and jot that down. Remember that sine is the y value and cosine is the x value. So technically we're going to take the y value and divide the x value. The y value divide the x value in order to fill these in. So first of all, let's start with theta equals to negative pi over 2. So we want to know what f of theta equals to. And that's equivalent to saying sine over cosine. Well, sine is y. The y value here is negative 1. And the x value is 0. We'll take a look. Negative 1 divided by 0 is undefined. So this is undefined. Okay, there is our first value. At theta equal to negative pi over 3, f of theta is going to be, so this is negative pi over 3, that's going to be negative radical 3 over 2 divided by 1/2. And if I type that in my calculator, negative square root of, let me get rid of that one because that looks more like a 3. If I type in my calculator, negative square root of 3 divided by 2, and then divide that by 1/2, you're going to end up with negative 1.7, negative 1.7. And that goes here, negative 1.7. Next, we have theta equals to negative pi over 4. And let me see if I can bring that down a little bit, just out of, I'll bring this one back up. So at negative pi over 4, f of theta equals to negative radical 2 over 2 divided by radical 2 over 2. So that's y divided by x. That's going to end up being negative 1. So this is negative 1. At theta equals to negative pi over 6, we end up with f of theta. Oops. Again, I keep writing that too high, but we can make space here. So our function tangent is going to be at negative pi over 6. That's going to be negative 1/2 divided by radical 3 over 2. And that is going to be equivalent. I plug it into my calculator. That's negative 0.6. All right, and then if we plug in 0, so theta equals 0. Oops, not theta equals theta, theta equals 0, then f of theta is going to be at 0. That's going to be 0 divided by 1, y divided by x, and that is 0. Okay. From there, we're going to go ahead and do pi over 6, pi over 4, pi over 3, pi over 2, the same way. And you're going to notice, so because of room, I guess I'll write it down here. I'm going to erase this for a second. Actually, let me make that a little bit smaller. And I guess I'll write it here, negative pi over 2. So I'm going to write it here and make some space. So at theta equals to pi over 6, f of theta is going to equal to 1/2 divided by radical 3 over 2. We did that over here, 1/2 divided by radical 3 of 2, but we ended up with negative 0.6 because this was negative. This is going to be positive 0.6. And you're going to notice that you're going to get a symmetry, only that this is negative and these are going to be positive. So for theta equals to pi over 4, we end up with f of theta equals to radical 2 over 2 divided by radical 2 over 2, okay, because that's what x and y is. So the y value divided by the x value is going to be 1. We have pi over 3, so f of theta equals to pi over 3. And I think you get the point here. Theta at pi over 3 is going to be equivalent, or not equivalent, but very similar to pi over 3, only that because this is negative and positive, this ends up negative versus this one is going to end up positive. So at pi over 3, the y value is radical 3 over 2. The x value is 1/2. And we end up with the same value here, 1.7. And if we go back to pi over 2, so if theta equals to pi over 2, our tangent is going to equal to, again, sine is 1, cosine is 0. 1 over 0, just like we started with over here, was negative 1 over 0. That's undefined. Okay, and that's how we get the values that we fill in for our tangent. Okay, remember f of theta, that's our tangent graph here. So I'm going to go ahead and fill these in. So we said that here it's undefined. This one was negative 1.7. This one was negative 1, negative 0.6. This was 0. This was 0.6. This was positive 1. This was 1.7. And then we have back to undefined. All right. So what I'm going to do now is I'm going to graph this. So again, here we have 1, 2, negative 1, negative 2. I'm going to go ahead and plug in my values. Negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 2, pi over 6. I don't know why I said pi over 2. That's where it started. Pi over 6. And then we have 0 in here. Pi over 6. Pi over 4. Pi over 3. And pi over 2. All right. So there it is. And then now we're going to go ahead and fill in what we know. So at pi over 2, it's undefined. So what I'm going to do is I'm going to take any color you want. I like the color purple, so I'm going to go ahead and use purple for my undefined. And I'm going to go ahead and let me see how thick that is. Yeah, I guess I'll use that. So here it's undefined, so I'm going to go ahead and draw a dashed line indicating that this graph cannot cross this undefined line. There's no passing through that line. Then at negative pi over 3, I'm going to go ahead and graph negative 1.7. So at negative pi over 3, here's 1. And then again, here's a half, 0.7. It's going to be about right here. I'm estimating. At negative pi over 4, it's negative 1. At negative pi over 6, it's a little bit more than negative a half. So I'm going to estimate a half there. So I'm going to go about right here where the 6 ends right there. And then at 0, it's 0. At pi over 6, it's 0.6. So a half is here. So a little bit more than that. Pi over 4, it's 1. Pi over 3, it's 1.7. So about right here. And then at pi over 2, it's back to undefined. So I draw my dashed line. All right, and we are going to go ahead and follow the graph. So bear with me. Okay, and then it goes upward like that. Let me try that again. So it comes in this way, and then it curves this way. It's connected, by the way. It's just very difficult to draw. I'm going to try that one more time. All right, and there is our tangent graph. Okay, so kind of goes from bottom up, bottom, and then it goes up and it curves up, and then it follows that undefined all the way up, getting very, very close to it, but it never passes it. And that is the graph of tangent from negative pi over 2 to pi over 2. So if we repeat this cycle, you're going to get infinitely this graph going to the left and this graph going to the right, and it cycles the same over and over. All right. Let us then jump to cotangent, which is a very similar scenario here. So for this one, cotangent, again here, remember cotangent, what's important to know, it's the reciprocal of tangent. So this is actually cosine theta over sine theta. And so again, this one completes its cycle between 0 and pi. And so we have 0, pi over 6, 0 to pi, right? And then so we're going to use pi over 6, pi over 4, pi over 3, pi over 2. And then we're going to use 2 pi over 3 because this one we're at the first and second quadrant. 3 pi over 4 and 5 pi over 6. All right, and similar to what we did before, I'm going to go ahead and I'm probably going to just show at least, how we get part of it, or we'll see how it goes. Maybe it'll go a little bit faster. But so long as we know that cotangent is the reciprocal of tangent, so the numbers aren't going to be exactly the same, but make this a little bit smaller in the corner. Lift this up a little bit. All right, and for this graph here, we are looking at from 0 to pi. So we're looking at the first and second quadrant. And so we'll start at 0. So if theta equals, first of all, before I even do that, remember that cotangent theta is cosine over sine. And remember that means you have x over y. Okay, so we're going to take the x value now and divide it by the y value. So if theta equals 0, then cotangent of 0 is going to be x1 divided by 0, which again is undefined. So this one is undefined. For theta equal to pi over 6, I'm going a little fast here because, again, we already did it once with the previous one, but I still want to go over so you understand what's going on. So cotangent of pi over 6, that's x, which is radical 3 over 2 divided by y, which is 1/2. Radical 3 over 2 divided by 1/2 ends up being 1.7. So if we get similar numbers, because these numbers stay consistent, right? The only thing that changes are negatives or positives, etc. So this is 1.7. All right, at pi over 4, theta equals to pi over 4, we end up with cotangent of pi over 4, and that ends up being radical 2 over 2 over radical 2 over 2. That's just 1. Okay. At theta equals to pi over 3, that is cotangent of pi over 3, which ends up being radical 3 over 2 divided by, actually, no, backwards, excuse me. That's 1/2 divided by radical 3 over 2, and that ends up being 0.6. Sorry, it's going downward, but I ran out of space and I want to keep going. All right, I guess I'll put the other one right here. At theta equals to pi over 2, cotangent of pi over 2 equals to x, that's 0, divided by y, which is 1. 0 divided by 1 is 0. That goes here. And then again, the cycle repeats itself, but let's take a look. So at theta equals to 2 pi over 3, that ends up being cotangent of 2 pi over 3 equals to, that's going to be x negative 1/2 divided by y, which is radical 3 over 2. Now, we have that here, but this is negative 1/2, so this ends up being negative 0.6. Okay, at theta equal to 3 pi over 4, cotangent of 3 pi over 4 ends up being similar to this one, but notice that the x value is negative radical 2 over 2, and the y value is positive radical 2 over 2, because again, in the second quadrant, x is negative and y is positive, right? In the first quadrant, they're both positive, okay? And so we end up with negative, in this case, negative 1. All right, at theta equal to 5 pi over 6, that's cotangent of 5 pi over 6. We end up with, that is negative radical 3 over 2 divided by 1/2. We know we're going to end up with negative, and we started with that here, radical 3 over 2 divided by 1/2. That's going to be negative 1.7, excuse me. And then our last one, you pretty much can guess it's going to be undefined because, again, anything that's equivalent to pi units is going to be undefined and plus or minus pi, right? So theta at pi is going to be cotangent pi, which equals to negative 1 divided by 0, and anything divided by 0 is undefined. So again, that's how we fill in our chart, by using those values of x and y. Remember, it's x and y values for all of these. Same thing over here, x and y for all of those. So let's go back and fill in our chart so that we can graph cosine over sine. So this was undefined. This was 1.7. This was 1. This was 0.6. This was 0. This was negative 0.6. This was negative 1. This was negative 1.7. And then we're back to undefined. So like the previous one, I like purple, so I'm going to keep the consistency with the color purple for the undefined. So the other thing is I'm going to fill in here we said pi over 6, pi over 4, pi over 3, pi over 2, and then we have 2 pi over 3, and then this is 3 pi over 4, and then 5 pi over 6, and then we have pi. And then again, this is 0 here. So let me go ahead and put down my undefined. So at 0, even though it's kind of hard to see, this is undefined. I'll write it again so you can see the purple here. All right, so that's undefined. And then we're going to go ahead and graph. At pi over 6, we got 1.7, so about right there. At pi over 4, we have 1. At pi over 3, we have 0.6, so that's about half, a little bit more. Okay. And then at pi over 2, we have 0. At 2 pi over 3, excuse me, that's negative 0.6, so that's about half, about right there. At 3 pi over 4, we have negative 1. No, that should be lower. At 5 pi over 6, it's negative 1.7, about right there. And then at pi, it's back to undefined. So I'm going to go ahead and draw my, I should make it on the line. Excuse me. All right, and there is connect the dots. So this one goes this way, and then it connects down to 0. And because it's hard, I kind of separate it. It should be all one graph, but it's kind of hard to draw, especially on the Mimeo. Let me try that again. Let me see if I can just do it this way. It's the best I can do. So this is cotangent theta. So it kind of goes, and then it kind of curves downward. So there is cotangent. Looks very similar to tangent, but again, because they are reciprocals of each other, right? You're going to have one going from bottom up, and then the other one going from top bottom, right? All right. Let us move forward to 2 more. So we only got 2 more, and then I'll stop the video for part 1 where we graph the parent graphs here. And now let's take a look at secant. So for secant, this one completes its cycle between 0 and 2 pi because, like I said before, secant is a reciprocal of cosine. So this is, secant is 1 over cosine theta, okay, which is equivalent to saying 1 over x. So we're going to go ahead and fill this in. This is going to be between 0 and 2 pi, so this is going to fill out. We're going to go ahead and, because if we count all of these and we split that up, we're going to go by pi over 4. So 0, pi over 4, so we can fit it all in there. Pi over 2. We're going to go with 3 pi over 4. That's second quadrant. We're going to go with pi. We're going to go with 5 pi over 4. We're going to go with 3 pi over 2. And then finally with 7 pi over 4 so that we can fit everything there. And again, like before, we're going to fill this out using that 1 over x, knowing that in this case secant is 1 over cosine, and that's just 1 over x. So I'm going to go ahead and take a copy of this like the other one, and we'll fill it in. Again, once you know how to do that and you can find the values, again, you can just copy and the numbers already, but because this is the first time we've ever graphed these before, unless you've taken Math 3 before and you've done it already, I want to be consistent in showing you how we get the values. So again, like before, if theta equals to 0, Again, we're looking at everything right now. We're going from literally 0 and going all the way around the circle back to 2 pi. But we're looking specifically at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, 3 pi over 2, I forgot that, and then pi over 2, and then back over here to 2 pi. Okay, so at 0, if we start there, that's saying, actually, let me do that before. Oh, actually, hold on. Let me erase this for 1 second and let me write down what we're graphing. So we are graphing a secant, right? Which is 1 over cosine, which is 1 over x. So therefore, at 0, secant, I keep writing theta. Secant at 0 equals to 1 over the x value at 0. So here the x value is 1, and 1 divided by 1 is 1. So at 0, secant is 1. At pi over 4, secant of pi over 4 is going to be 1 over x. Pi over 4 is radical 2 over 2. And if you take 1 divided by radical 2 over 2, you end up with 1.4. So this is 1.4. At theta equals to pi over 2, this is secant of pi over 2. That's 1 over, and then pi over 2, that's x value, that's 0. And 1 divided by 0 is undefined. Okay. Now we have, if theta equals to 3 pi over 4, that's secant of 3 pi over 4. That's going to be 1 divided by x, which is negative radical 2 over 2. So that's going to be negative 1.4. All right, and then at pi, secant of pi equals to 1 divided by, well, that's going to be x value, which is negative 1. So we end up with negative 1 as our answer here. At theta equals to 5 pi over 4. Oops. That's secant of 5 pi over 4. We're going to end up with 1 divided by, and then at 5 pi over 4, x is negative radical 2 over 2, which we got, what was it, negative 1.4. And then we have actually theta equals to 3 pi over 2. So that's secant of 3 pi over 2, which ends up being 1 over 3 pi over 2. That's x is 0, so that's undefined. 2 more. If theta equals to 7 pi over 4, secant of 7 pi over 4, that's 1 over the x value, which is radical 2 over 2, which is positive 1.4. And then for theta equals to 2 pi, secant of 2 pi is going to be 1 over, and we're back over here. So the value of x was 1, so this is going back to 1. And there are our numbers for secant and where we got them from, okay? And so I'm going to go back and plug those in. So at 0, it was 1. At pi over 4, 1.4. And then we had undefined. And then we had negative 1.4. And then it was negative 1. And then again, negative 1.4. and then we had another undefined, and then we go back to 1.4, and then back to 1. Okay, so these all are equivalent of 1 unit. -2, -3, -4. And these I'm going to go ahead and plug in. In this case, it's going to be zeros right there. So this is going to be pi over 4. Next, pi over 2. Next, we're going to have 3 pi over 4. Then pi. Then 5 pi over 4. Then 2 pi, actually 3 pi over 2. And then we have 7 pi over 4. And then we have 2 pi. All right. A second, I'll put some chapstick on. Lips are getting dry from talking so much. All right. All right, and now we're going to go ahead and just put the points in. So let us do that. I like using blue for the parent graph. So first of all, at 0, it is 1. At pi over 4, it is 1.4. 1.4, a little less than a half. So about right there. At pi over 2, it is undefined. So I'm going to go ahead and draw in purple just to keep it consistent. Okay. I keep going over the line, but it should be on this line here. All right, and so there it is. And then the next one, we're at 3 pi over 4, which is negative 1.4. So that's about right there. And then we have at pi, we have -1. At 5 pi over 4, it's again negative 1.4, about right there. And then at 3 pi over 2, it's undefined again. At 7 pi over 4, it is 1.4. And then at 2 pi, it's 1. So for the graph of secant, I always call it like a unhappy face, but you know, it's just kind of how I view it. I don't know. Maybe it's just me. But this goes like this. Hold on. So it should be more curved. This one is like this. And then this one goes like this. And that is secant theta. All right, and so that's secant, which is the reciprocal of cosine. And the last one that we have here is cosecant. So cosecant, again, is the reciprocal of sine. So again, we do pretty much the same thing like we did with cosine, 1 over cosine, but again, the numbers are going to be a little bit different in terms of order, but it's very similar because we're still using the unit circle. So for cosecant, again, it finishes a cycle between 0 and 2 pi. So I know that this is going to be 0 to 2 pi again. And so again, I'm going to go by pi over 4. So this is going to be pi over 4, pi over 2. This is going to be 3 pi over 4. pi, 5 pi over 4, 3 pi over 2, and then 7 pi over 4, and then back to 2 pi. So again, we're going to get the graph of that. This is pretty much the last time that I'll show how to find those numbers for these, because again, I have it consistent on here, so you could always rewatch the video of how I get these values. This is the last time we do how we get these values. So again, we're looking at values between the whole unit circle again. So we're going from 0 to 2 pi, but again, we're looking at 4 pi, 2 pi, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and then back to 2 pi, which it starts at 0, by the way. So this one, remember that we're graphing cosecant, and cosecant is 1 over sine theta, which I hope I wrote here. Let me see. Yeah, I did. Okay, so that is equivalent to 1 over y value. The last one we did for secant was 1 over x. This is 1 over y. So at theta equal to 0, cosecant of 0 equals to 1 over, and then we go y value, that's 0. So for this one, 1 over 0 is undefined, so we're going to put undefined there. Then at 0, at pi over 4, we have cosecant of pi over 4. That's 1 over the y value at pi over 4, which is radical 2 over 2, which is 1.4. Theta at the next one, which is pi over 2. Cosecant of pi over 2 is 1 over the y value, which is 1. And that's going to end up being 1 divided by 1, which is 1. Okay. If theta equals to 3 pi over 4, cosecant of 3 pi over 4 is going to be 1 divided by, at 3 pi over 4, the y value is radical 2 over 2. We have that over here. That's 1.4. All right, for theta equals to pi, that's cosecant of pi, which is 1 over, and then at pi, the y value is 0. That's again undefined. At theta equals to 5 pi over 4, cosecant of 5 pi over 4, that's 1 over, at 5 pi over 4, that's negative radical 2 over 2. That's going to be negative 1.4. Okay. At theta equals to 3 pi over 2, cosecant is of 3 pi over 2 is going to equal to 1 divided by, the y value is negative 1. So that's 1 divided by negative 1 is negative 1. 2 more. 7 pi over 4, cosecant of 7 pi over 4 is going to be 1 divided by, this one is, again, the y value. That's negative radical 2 over 2, which is negative 1.4 again. Okay, and then lastly, theta equals to 2 pi, cosecant of 2 pi equals to 1 divided by, and at 2 pi, the y value is 0, so this is back to undefined. All right, so from our unit circle, that's how we got all the values of cosecant. I'm going to go back and fill those values in so we can finally graph our last parent graph for part 1, and then we'll do transformations and all that in part 2. That way you can kind of take a look at the first part, fill it in your paper, and then part 2 when you're ready to go and move forward. So this one was undefined. This one was 1.4. This one was 1 This was 1.4. This was undefined. This was a negative 1.4. This was negative 1, negative 1.4 again, and then undefined. So I'm going to go ahead and fill these. Again, these are equivalent by units of 1, negative 1, negative 2, negative 3, etc. So here, we're going to start with pi over 4. Then we're going to go with pi over 2. Then 3 pi over 4. Then we have pi. Then we have 5 pi over 4. Then we have 3 pi over 2. Then we have 7 pi over 4. And then we have 2 pi. And I'm going to go ahead and graph. So the very first one again is undefined at 0. So I'm going to go back to my purple for undefined. And 0, it's undefined. So I'm going to go ahead and draw that in. At pi over 4, it is 1.4. So it's a little less than a half. I estimate it. At pi over 2, it is 1. At 3 pi over 4, it is 1.4. So it's back up here, kind of matching that one. Should make it a little lower because that looks like a half. So just about right there. At pi, it's back to undefined. So I'm going to draw in my line here. At 5 pi over 4, it is negative 1.4, so about right there. One little dot. Okay. At 3 pi over 2, it's negative 1. At 7 pi over 4, it's negative 1.4 again, kind of matching that one. And then at 2 pi, it's back to undefined, so the graph doesn't cross that path there. So let's connect here. We have a graph like this. Not even touching the dots there. Let's try again. That's going upward, and this one is going downward. And this is cosecant theta, which is the reciprocal of 1 over sine theta. And so there is the graphs for our parent graphs: tangent, cotangent, cosecant, and secant. So like I said, I'm going to stop the video here, pretty long video, to graph all of these with detail. In part 2, we will see a little bit of amplitude and period and some transformations, etc., etc. That's going to be in part 2. So like I said, I'm going to go ahead and stop the video, and you'll see part 2 up there also. I'll see you in the